And if you have any questions about Zoom, if you're having any problems with your technology, you can private chat me. You can select Karen During off the list of people to send a chat to, and I'd be happy to try to help you figure out what's going on. And we are now streaming live on Facebook.
Yep. Sorry, it takes a few seconds for the authentication token to go through to confirm that this is in fact our meeting and not being hijacked by somebody else. So I think we should be good on all fronts. So the goal for today's series of presentations is mostly just to thank you, our volunteers, far and wide across Virginia's coastal plain, helping us map the king tide this year on October 18th, 2020. Now, it was kind of a year that was fraught with a lot of difficulty, but we just wanted to share some remarks virtually, since normally each year at the end of the year, about a month or at least a few weeks after the king tide takes place, it gives me the chance as the scientist to kind of review all of the data that you've collected and provide some insights to report back to you, our volunteer pace. And thank you for all of the efforts that you conducted this year, capturing these beautiful photographs behind me, but also the infinite efforts that you've continued to provide as you've gone through the process of collecting data year-round. So we kind of have a loose program that we're planning to follow along with, and I wanted to pass things over to Dave Mayfield, our founder, to provide a little bit more feedback to you guys as our citizen science base. So thank you very much. And you want to take it away, Dave?
Sure. Thank you, Derek. Well, I just wanted to, first of all, thank everybody for joining us this evening. And I'm going to have probably the shortest remarks, definitely, I hope. Just a little history. I was an environmental reporter with the Virginia Pilot when just sort of a very rough idea for a citizen science project along the line of Catch the King came to mind. And the very first person that I called, even before I talked to my editor about this, was Skip Stiles. And when he said he thought it might have some merit, the person I called after that was Derek. And I really consider that those two guys the co-founders of the project. And without them, this never would have come about. And it's just been such a fun ride to see so many people embracing the chance to get out there and be part of a group effort to really get a handle on this very, very important challenge that we have here with sea level rise and tidal flooding. I was just mentioning to Derek before some of you all got on the line, I really would love to know the age range of the participants in our events, because I know we have kids who are participating with the help of their parents or some other elder, probably younger than 10. And I know we have volunteers that are into their 90s. So it's great to see such a wide range of people. And we're going to continue. It's been quite a challenge with COVID. I was pleasantly surprised at how many people came out this past year and did this with next to no effort on our part to publicize this event, because we just really felt that it wasn't going to be a good idea to encourage people to be gathering together with this pandemic amidst us. And we have some pretty high hopes for next year if we can get past the COVID-19 threat. And just one quick one I'll mention is, we're really hoping to reignite what have been some very promising talks with the Girl Scout Council of the Colonial Coast, which has the Girl Scouts have a new citizen science merit badge, and the Colonial Coast Council has been really interested in using Catch the King as a platform to help their young girls attain this citizen science merit badge. And we envision, potentially hundreds or even thousands of scouts at some point participating in a project like ours, or perhaps something else that was inspired just by getting to know our project. So again, thank you so much, everyone who's in here tonight. Tell your friends who aren't joining us, who participated. My deepest thanks, and I hope to see all of you again in the next year.
Indeed. Thank you. Appreciate it. So I know a lot of the excitement that we've been able to enjoy, I guess, with this year's Catch the King has ultimately kind of been underscored by COVID-19. I think our main focus this year is kind of really just to thank you, our seasoned volunteers, that have kind of gone through this process so far of collecting data with us over the last couple of years to really help us kind of better understand specifically all of the data that we've been able to collect. So I'm going to share my screen so that you can actually see a presentation I've put together for you specifically related to our King Tide monitoring event. We're certainly appreciative of all the educational opportunities that this has kind of provided for our volunteers. So thank you again. So our focus is this is kind of a thank you and data review event. It's really just to kind of focus on providing some data validation related to our flood forecast models using the data that you, our citizen scientists, have collected. So as we're kind of, apologize as I look back here occasionally, also looking at our Facebook live stream and what's visible there. They're on about a 20-second delay from what we got here on Zoom. But I'm assistant research professor at the Virginia Institute of Marine Science within their Center for Coastal Resources Management. And a lot of our background really focuses on coastal flooding. A lot of our partnerships with the Commonwealth Center for Recurrent Flooding Resiliency and other flood monitoring projects like StormSense throughout coastal Virginia has kind of really allowed us to better understand specifically how king tides, along with storm surge from extratropical and tropical storm systems, and even compound flooding from rainfall like events from today are ultimately changing the shape of our landform as we kind of look forward to what you might see in the coming weeks, months, years, and even centuries in coastal Virginia. So the format of this presentation kind of takes the format of a thank you up front. So I know a lot of presentations tend to have the thank yous at the end, but this one kind of starts at the beginning because without you, our volunteers, we don't really have a lot to present specifically related to the science. The beauty of a citizen science project is that anyone of all ages can really kind of help us with a relatively intuitive app, collect data, and allow us to quickly analyze the results and provide feedback, not just to you, our volunteer base, first and foremost, but also to pass that information along to key decision makers in our communities who will help us kind of look at these data and make some decisions looking forward. Because ultimately, as we know in this paper from Paul Esser and Larry Atkinson on the right-hand side of the screen, their paper in 2015 kind of reviews a series of local projections between 4 and 8 millimeters per year of sea level rise is projected looking forward. And over the next 30 years or so from here in 2020 looking forward, things are going to change quite a bit in the region, depending on what types of projections we're expecting to see. And of course, the Center for Coastal Resources Management, where I work at the Virginia Institute of Marine Science, the College of William & Mary, has our separate projections where we're tracking what the National Oceanic and Atmospheric Administration has to say about the matter, but also the U.S. Army Corps of Engineers. And many of these individual groups have different projections that they're making decisions on a national level scale, specifically how our nation is planning to respond to this relatively imminent threat. And of course, as we all know, storm surge tends to only compound on top of the influences of sea level rise on a more than regional scale. So the beauty of this is that we have products that help us view not only what we expect to see in terms of long-term flooding, but also relatively short-term in the next 36 hours. We have our TideWatch products in terms of both time series charts and maps that kind of provide us some idea of what things will look like in the future. So this slide kind of represents water levels at Sewell's Point and Norfolk. I've shown this a couple of times over the years because it's a great way to illustrate how we've used the sea level rise app. All those little blue dots, starting with Hurricane Arthur in 2014, was kind of how we started to map using the Sea Level Rise mobile application on iOS and Android platforms. And the goal is really to validate flood models like those that I develop at VIMS, but also those from other scientists across the United States and the rest of the world, kind of directly relate to what we're expecting with different types of storm events and what we're kind of learning as we look forward to the future. So as you can see in 2015 here in Hampton Roads, the Waukeester, as we often have called it with Hurricane Joaquin, was mapped several days over. Each time you see this line increase and the color change to red is essentially above 4 feet above mean lower low water at the gauge there in Norfolk. And of course, we have multiple water level gauges throughout Virginia's coastal plain, but this one has kind of been our litmus test for a lot of us, especially in Southside Hampton Roads and even those in the peninsula in Virginia, that kind of represent specifically where you expect to see flooding. So every time that line becomes red, our goal is mainly to try and get some volunteers out there to collect data. And occasionally we'll get a random nor'easter like the one you see there in January pop up. But for the most part, a lot of our flood events tend to take place in the fall, mostly due to the compound influences of plants not absorbing nearly as much water at that time of the year, but also the leaves that fall off of those plants after senescence takes place usually tends to clog up a lot of our storm drainage systems. So on multiple levels, we tend to have flooding take place. And so our goal over the last several years with Catch the King and its inaugural year in 2017 until now is we've now collected 40 years worth of data. And each of those individual blue dots that you see here on this map essentially represents mapping events that have been set up either directly by our volunteers or our volunteer coordinator, Karen Jekilish, who has helped us collect a vast amount of data and trained many of you as our volunteers throughout the years. And so based on the data that you've helped us collect, this kind of belabors the point a little bit, but basically the idea is that we've collected a very large amount of data. Over the last 5.5 years, we have collected over 160,000 GPS high water marks. And that's a truly astonishing amount of data over such a large period of time. And so I'm going to kind of skip on to the next slide because for the most part, the goal is really to illustrate that the efforts can both be represented temporally and spatially to help us validate our models. As you may have seen over the last year and a half, our efforts have been covered by the company that develops the software ArcGIS, which is a geospatial mapping platform. And their chief science officer, Don Wright, featured a lot of your initial efforts in 2017 with Catch the King and ultimately was featured at their conference in 2018. Science Friday with Ira Flato featured a lot of our efforts last year on NPR, but also most recently this year in 2020 in January, CBS This Morning also covered a lot of the efforts directly related in Norfolk and interviewed several of you as individual volunteers to help showcase and kind of highlight a lot of your efforts in mapping this type of flooding event. And of course, finally, just a few weeks ago, we were also featured on the national platform again on the Weather Channel several times over for a lot of our citizen scientists' efforts, specifically focusing on mapping year-round flooding. So the real goal behind a citizen science project is to kind of give us a large amount of data to work with and allow us to, from my perspective, validate models, but the data do so much more than that. In this case, our goal is really to visualize tomorrow's flooding today. In this case, it helps us build a data-driven model. Now we have 4 years worth of Catch the King data to work with from 2017 until the year 2020. And while certainly the conditions of the flooding each year varied slightly, our goal is to target the highest astronomical tide of the year, or the king tide, use it to validate the models and flood forecasts, but also using the link in the bottom left-hand corner at vims/people/my name followed by Catch the King, you can view and interact with these maps yourself. So our goal is also data transparency. In this particular case, you can kind of spatially track inundation to improve these models as we looked at flooding during a regular king tide in our inaugural year on November 5th, 2017, and then again on the 28th of October in 2018, and again on the 28th of night in 2019, followed by this year on the 18th of October 2020. All of these individual maps have kind of compounded to provide that background map that you see there. So a lot of our volunteers will oftentimes ask us, where are some new places that haven't been mapped previously? There's some value to mapping the exact same place multiple times over because it gives us a series of data each year and what represents the highest astronomical tide for that location. But also mapping new locations helps us as your data have literally validated our model, starting with Southside Hampton Roads and allowed us to move further on to expand the extent of the Tidewatch map throughout Virginia's coastal plain. So thanks to you, our many volunteers, we held multiple virtual training events this year due to COVID-19. We didn't offer any in-person training. We had 184 of you gather on October 18th, and you collected 27,700 GPS high water marks and 114 images, several of which you still see kind of scanning behind me. Now, of those people, we also had 42 individuals that continued to help us map flooding year-round. There are events in February, July, August, and again, of course, in September, October, and some of you have even mapped this month in November, as we kind of attempt to map a lot of these different events throughout the course of the year. While our participation was understandably lower this year due to the pandemic, ultimately our goal is still to collect valuable data, and you did just that. So we applaud your efforts and greatly appreciate and thank you for them. Now, naturally, we also thank our media partners. I know we didn't get directly engage a lot with the media organizations beyond those I previously mentioned, but ultimately every year I usually develop an interactive story map, which kind of illustrates on kind of a digital scrapbook, specifically what the data are used for, how they're measured, and specifically where are some key locations that would be useful for you to help us monitor. And naturally, of course, we really appreciate the efforts of the Hampton Roads Sanitation District and AECOM for ultimately supporting us financially to help us drive this effort, as citizen science projects are generally relatively inexpensive, but they are not completely free. So we greatly appreciate their sponsorship and effort in this participation. But also media partners really allow us to get the word out there. For example, in 2017, we had over 10,000 page views by the time that our initial Catch the King event took place. And as we kind of track these individual stories that are written by reporters, such as Dave Mayfield, who spoke previously, formerly of the Virginian Pilot, these really have allowed us to kind of garner a lot of that citizen support in our communities. And this project really doesn't work without you. So due to your Herculean efforts, we collected 59,718 high water marks back in 2017, and that garnered the Guinness World Record for us as the largest environmental survey on the planet. And of course, we are still the record holders as of today. But really the goal behind that is that we collected such a large amount of data that it makes it kind of difficult for communities to not directly interact with the information we have collected and that you have provided. We'd also like to thank our civic organizations. The Girl Scout Council of the Colonial Coast collected a massive amount of data points among their 24 mappers at 4,630 high water marks. So excellent job. We also had our partners and master naturalists and master gardeners, many of whom Karen During trained herself remotely during the months of August and September, and they collected 5,971 GPS high water marks, largely centralized in the Middle Peninsula and northern neck of Virginia among their 47 mappers across multiple cities and counties. So we have great appreciation for a lot of your efforts, since I know our normal media machine directly engages a lot of school teachers, and many of our schools are still participating in school virtually. Our integration with the school system didn't nearly garner as many of our individual student volunteers as we normally would see in our previous years, thanks to the efforts of the Baton Environmental Education Initiative. Now, of course, it feels weird to thank myself, but of course I'm not the only person that is a flood forecaster. There are many scientists that have been able to interact with the data that you guys are collecting, as we do share the data publicly. We have products called our sea level report cards, which look directly at sea level rise as projections, but also specifically within a 32-hour window. We've got our Tidewatch map and Tidewatch charts. And specifically, our Tidewatch charts are basically time series data that are collected over time. And in this case, you can view a vast network of sensors that are a conglomeration of the National Oceanic and Atmospheric Administration's gauges, along with the U.S. Geological Survey's gauges. And our Tidewatch maps provide forecasts based on their data, along with a series of citizen science and city-owned sensors. This is a sensor from the city of Newport News, for example, within the StormSense project. And ultimately, all of those individual data are disaggregated and placed in one place so that you can actually see all of their data. And this gives us, at a glance, what's happening throughout Chesapeake Bay, whether it's in NOAA's network, USGS's network, or one of these city-owned networks through StormSense. All of these are ultimately compounded, and we calculate relative error in the form of root mean squared error, or abbreviated RMSE. And we translate those into SI units and centimeters, mostly because they're prepped for publication. And that's why on an international platform, if we keep our data in those units, we can not only benefit our own communities here locally, but also international communities that are directly having issues with sea level rise as well. And so it gives us kind of a metric or litmus test to ensure whether or not our data are performing accurately at any of the sensors within our states. And of course, within the Commonwealth of Virginia, we can't put sensors everywhere, so that's the beauty of citizen scientists. So this is our model called TideWatch. It ingests 2.4 gigabytes of atmospheric data in terms of wind speeds and air pressure, and turns that into a surge guidance product. And it provides us this opportunity to map flooding up to 36 hours in advance. And on a spatial scale, about every 3 feet or 1 meter in resolution is the scale of every pixel on this map. So you can zoom into individual areas, and you'll find that our model updates twice daily at noon and midnight, providing hourly outputs. So our 36-hour simulation basically uses 72 computers or CPUs in our high-performance computing platform at the College of William & Mary to essentially, in a very simple way of stating it, visualize tomorrow's flooding today on our TideWatch map. This model automatically updates twice daily at noon and midnight. So every 12 hours, there's a new 36-hour forecast looking forward. And this is the product that we're essentially using to compare your results with. So last, of course, we need to thank the app developers, Skip Stiles, along with his partners that have helped fund the Sea Level Rise app and ultimately obtained the grants to basically provide the genesis for its foundation. In this particular case, the data that you collect and the GPS high water marks form breadcrumbs that we can compare with the TideWatch map that I just showed you there. So on the left-hand side of the page are sea level rise app data, and on the right-hand side of that figure is specifically what our forecast looks like at a particular time interval where this individual collected data. So your GPS data are, of course, timestamped, and then we select the appropriate time interval in our model to compare your data with. And in some cases, depending on the year, I have this legacy figure from the right-hand side to illustrate that in some cases, depending on whether or not a hurricane lands directly over top of us or grazes us, the influences of king tides can actually be greater than the influences of hurricanes if you only get grazed by them, as is seen in this example from September in 2018. Now, when we examine what this looks like, for those of you that aren't familiar, the iOS and Android platforms, you can view this on a tablet like the iPad interface that's seen here. And basically your GPS high water marks are put into what we call a geographic information system. Those points are then converted into a contour, and you'll see an attribute table here that you can open in programs like Microsoft Office Excel, or of course ArcGIS, which is a geospatial mapping platform. And essentially what this allows us to do is form a contour of those points and then compare it with our model. And then kind of using the distance formula, which many of you have learned in basic mathematics classes, we look at how far each of those individual points that you, our volunteers, collected with the data that our model predicted using the cell center points of each of those individual grid cells or pixels. Since the elevation of the water level in each pixel is assumed to be the same, we translate that into a mean horizontal distance deviation or difference. In this case, it is 7.16 meters, and our model's scale resolution is usually about 5 meters in resolution based on aerial survey data that is collected every 5 to 10 years. And throughout coastal Virginia, we use these data to help validate our model's assumptions for elevation accuracy. So in conclusion, basically, you guys collect a bunch of data. Our goal with data transparency is to make our TideWatch forecasts in terms of our maps and charts available using these interactive mapping tools. You can see what the data look like as you zoom into different places, whether you're looking at Norfolk, Virginia Beach, Hampton, Newport News, Chesapeake, or even all the way on up to Richmond County in the northern neck and parts of Northampton County and the eastern shore. Throughout coastal Virginia, your data points are timestamped on these maps, and you can interact with them directly using the URL that's available there below. And the beauty of this tool is, of course, of individuals of all ages can kind of see and very transparently see the blue shaded areas, what our model predicted was the highest astronomical tides flood extent for the year, and you can measure directly within the maps interface what your individual data points represented and compare them directly to what our model had actually predicted for that event weeks, or even months before the actual event took place. And that's really the beauty of king tides, is that you can predict them months in advance. But of course, our model's not static. It is time dependent. So in some cases, we directly translate the data that you collect in your timestamps and compare them to the nearest model prediction. In this case, we're doing hourly outputs. You can compare 8 to 9 a.m. versus 9 to 10 a.m. using last year's king tide data in a paper we recently published in the year 2020. In each of these cases, you can see in our mean horizontal distance deviation, for this example in the city of Norfolk, or another example here in the Lafayette River in Norfolk near the Haven Creek boat ramp, a famous space that many of you have mapped over the years, and some of the areas of Llewellyn Avenue that flood regularly. Or some of these areas in the city of Virginia Beach where you can see inundation taking place next to ephemeral creeks that meet up with estuarine environments. In many of these individual places, we're starting to see these ephemeral creeks that normally just have water in them when we get heavy rainfall are now starting to see water intrude upon them during heavy water level events, sometimes compounded with rainfall, other times just driven by tides during our king tides. So the consideration that's involved here is really we're crowdsourcing hydrologic correction. And what that means is essentially we're testing the underlying assumptions for a hydrodynamic model and how accurate its representation of reality happens to be when we consider things like elevation. Is it actually correctly assuming that water should be able to pass underneath this bridge in the city of Virginia Beach? We've used this example quite a few times because it's really a great example of how some of these heavily canopied areas, when you consider an aerial survey that's trying to measure elevations, it's really hard for LIDAR, or light detection and ranging, as the acronym stands for, allows lasers to kind of pierce through the foliage in these trees and ultimately allow us to identify where this creek should be. Previously, it was not in our model in the year 2017, and we corrected this again in year 2018 to ensure that water could actually flood underneath these areas. Since our model attempts to be volume conservative, big areas that are missing, like even you can see from the satellite imagery, that this dark area in the imagery, what this mean horizontal distance deviation tells us with you, our volunteers collecting these data, is that we're noticing some of these blue dots that are way down here in these streets in the city of Norfolk, very far from the edge of where our model predicted flooding to take place. Now, since our model is volume conservative, the water that should be in this area that's highlighted here, once we've fixed the model, is ultimately being displaced somewhere else. In this particular case, that causes over-prediction of flooding in places where it shouldn't be, and of course, under-prediction. If I back up one slide, you can kind of see where it's missing this entire area where there should be ephemeral water that is ultimately standing there during our highest astronomical tide of the year. And so, of course, I'm not an entire stranger to this. A lot of my dissertation research that was published in 2014 focused on very dense urban environments like New York City. And in this particular animation, you can see where water was ultimately not able to pass through some of these spaces in the city and the borough of Brooklyn. And so as you start to explore where water should be and where water shouldn't be, a lot of these hydrologic correction factors are pervasive throughout parts of coastal Virginia, especially in areas where these digital elevation models haven't been corrected. And in many cases, they cost hundreds of thousands of dollars for a firm to go through and actually do a lot of these elevation corrections. And a company that's done a great job with that so far has been Dewberry in the city of Virginia Beach. But a lot of individual organizations, it costs a very large amount of money to hydrologically correct every single small culvert in all of these different areas. So in conclusion, the key elements are we fixed hydrologic correction, is kind of illustrated there on the right-hand side of the screen. There's also results that Alfonso from Old Dominion University after me will kind of tell you a little bit more detail specifically related to how our environmental concerns are directly related to king tide, as a lot of the fertilizer that we tend to put on our lawns here in the fall in preparation for the winter tends to get flushed into the estuaries. And so nitrogen and phosphorus are key elements of concern when we look at nutrient loading due to king tides. Our 2020 flood forecast, evaluating the results, and just was able to finish calculating these earlier this week on the vertical scale. It's plus or minus 1.67 inches based on all of the individual data points that you collected, all of the sensors that we were able to compare with, gave us this vertical measurement, whereas the horizontal measurements were directly compared to contours based on the data that you collected. We turned this into an interpolated model, and this gives us information to work with looking forward to the future. Beyond hydrologic correction, we also learned quite a bit from year-round flooding events. Many of you helped us map the nor'easter that kind of formed in the remnants of Hurricane Sally in September, and we're still continuing to examine some of the results from that event and help us make some hydrologic correction results attributed directly to that event. And so based on the 4 years worth of data that you've helped us collect with this event, we just want to say thank you for all of your extraordinary efforts training others how to use the app, parents and guardians that have gone out and helped their children and many of their students directly interact with the results and learn a little bit about this fun environmental science project. We just greatly appreciate your efforts. So thank you. At this time, we've got a couple of moments for question while I pass things off to Alfonso.
There aren't any specific questions for you in the chat box.
I was seeing that, yeah.
Are there any on Facebook for you?
I was just switching over now to check and see. We have likes on Facebook and very kind of Jim Reddick from Norfolk's Emergency Management. So he just said excellent work, which will improve our planning efforts. So well done. So no questions on Facebook either.
Yeah, can I give you a question?
Yes, please.
You mentioned about some people measuring more or less throughout the year. I've only gotten 3 or 4 maybe notices for this year, and it could have gone many times more than that. So I don't know whether you have all the people that you need or how that's working.
So that's a great question, Bill. I mean, this year, ultimately, we didn't request as much assistance from volunteers, mostly in the interest of safety. Mapping near several other individuals, especially in urban environments, has been problematic for some. But of course, if you live in a rural area, your collection and data is particularly useful for us. Sure, there's probably more events that we could have posted this year, but for the most part, our main goal is really to kind of map beyond the king tide annually with Catch the King. Our real focus is to kind of track the highest astronomical tides in September, October, and November. And then if there happens to be a major flood event, usually Skip Stiles has been very useful at kind of tracking what the National Weather Service is saying. And our partners at the Wakefield Center there near Southside Hampton Roads. And really a lot of the help that's been involved with that is they will kind of let us know if there's a major flood event, and then we'll try to attempt to mobilize and set up an event where our volunteers can collect data. So you're correct, that only really happened about 4 times this year, whereas that time series that you saw probably had 8 or 9 events of red lines where the water level exceeded 4 feet above mean low or low water. Nowadays, I think we've found that it exceeds 4 feet above mean low or low water probably over 60 times this year. But really the goal is to map those events where it's over that water level for more than a period of 3 hours. That gives our volunteers enough time to mobilize and get out there without detriment to their safety.
Mm-hmm.
Does that answer your question?
Yes, it does. Thank you.
Thanks, Bill.
There's a couple of questions now, Derek, about where to map. There's 2 questions that are related. One is, when I'm out mapping, I run across other volunteers mapping the same area, and do you want duplicates? And another question is it possible to indicate if you'd like a particular site mapped? I'm not sure if where I'm mapping is the most helpful area to go.
Thank you for laying those questions, Karen. So, I mean, the real challenge that we kind of find ourselves in is that we're always finding new places that are in the public right-of-way for us to map. In this particular case, most of the places that are relatively new to map are always useful. But in this particular case, we're going to pass things over to Alfonso here in a second, but let me see if I can share my screen and kind of give you an idea of specifically where you can help us collect data to map. So as I'm sharing my screen here, the goal with this effort really is to kind of help us directly map where results are available. And a lot of you through Catch the King, this is just on my the Virginia Institute of Marine Science Facebook page is also linked to this. But as we pass this over, you'll see that there's a lot of different ways that will kind of give you an idea of when to map. Many of you used our tidal flooding calendar this year of 2020. And as you can see, most of the time we're trying to focus, I'm going to zoom in a little bit so that's easier to see. We tend to target a lot of these weeks where we call them king tides. And usually you can click on these and it will even take you to a page that will give you more information on exactly where you can map these individual events. For Catch the King in any given year, you can interact with the map data that I just covered, along with, you can see some of our new publicity information. Any of these that you click on will take you directly to the page for that year's mapping event. For example, this is the 2020 data collection just from a couple weeks ago that you helped collect, and you can see the map is kind of color-coded in yellow that will show you where all the individual data that were collected for this particular year happens to be, but also where you can download the data, and of course a link to where you can join us today on Zoom. The main key of this is that if you're curious about where to map, we built this new map on just the regular Catch the King page. And every single year's worth of data is available within this map. You can kind of zoom in and zoom out, or you can put it in full screen in a different page if you wanted to. And in this particular case, you can focus on any area within the coastal region of Virginia, along with our model's flood forecasts for each of those years. So the blue dots are our inaugural year from 2017. You can click on any given point and see this giant point represents 3,297 high water marks. And I can click the button to zoom in and see, well, how many individual points have been collected in this particular space. And this shaded area is what our model has predicted. And of course, because as I mentioned earlier, this is all of our data from Catch the King over the last several years, which represents nearly 160,000 high water marks. You have to give your computer a second to catch up as it tries to draw all of these dots and disaggregate these large points. But all of our data from all of these years are visually evident on this map. And I'm getting a little bit impatient waiting for it to load these points. There we go. But each of these will show you the individual times that they were collected by year. And what this means, of course, I've zoomed in on an area where we have several years worth of data that have been collected on this map. But if you zoom into specific rural areas or areas that you think may not have been mapped and you see no dots there from the last 4 years, that's probably a good indication that that area has not been mapped previously. Maybe not during Catch the King. And of course, you can type in specifically your location or even give the privileges to the computer to use your current location. And it can zoom in directly to where you're located. And then you can navigate from there to help you identify a new place that you haven't mapped before if you're curious as to whether or not it's been indexed in Catch the King's inventory. Do you think that answers the question, Karen?
Yeah, I think that really looking at the maps of where data has been collected before is one reference, and then each of us can work together before we go out mapping next time and sort of look for areas where data is missing. But I don't think it hurts to repeat areas again, and it also doesn't hurt to have more than one person mapping the same site. Is that correct, Derek?
That is absolutely right. In fact, you kind of saw on some of the figures that you had different people mapping at 8 a.m. and then 9 a.m. at the exact same location. Our model has a different prediction at 8 a.m. than it does at 9 a.m.
I just
So in
wanted
this
to
case,
clarify for Marina who asked the
spatially
question
validated.
that duplicates are okay. And we've also have some other questions that are sort of coming in, but for the sake of time and to keep the program
Yes, please.
going first hour, we will have an optional 30-minute session to answer some more of these questions. And we can also follow up with some of these answers to these questions after this event as well.
That's right.
So if we, because I know Joe Bouchard has some, example of how he provides maps to guide his mappers. So this may be something that we can help document in the future. But for the sake of time, is it okay if we move on to hear about Measure the
Certainly.
Month?
Yes, Alfonso, are you ready?
I am here, but I wanted to mention something. I don't know if you saw the email that I just sent to you and Karen and Skip. The Ghent area, it was an emergency one, sorry. The Ghent area lost power. I don't know how big it is, but I know that it's like at least a couple blocks. So I'm like that's why I'm completely dark right here. I'm connected to the hotspot of the phone.
Oh, wow.
But I don't know if my computer is going to last enough. So I'm going to
I heard, yeah, the power outage. Okay.
Yeah. I don't know how
You
many.
are in the city of Norfolk, and you had a lot of that wind that we're experiencing throughout the day here.
Yeah, so I don't know also how many of the volunteers were missing because of that. So it's like I'm connected to the phone, but it's my computer, the part that I'm worried. I don't think it's gonna last the whole thing. But I send the presentation.
Apologies, I did see your email, and that's why I was kind of a little bit of stalling for time as we were answering questions.
Yeah.
Do you think you're able to share your screen now?
Yes. Let me try to.
Excellent.
Share screen and start. Okay. Can you guys see the presentation?
Yes, you can see everything. Thanks, Alfonso.
No reacting. So again, I'm gonna try to. So, okay. So I'm gonna try to go a little bit faster than the 10 minutes because I don't think the computer is gonna work. So if I'm not here, I don't know, Margie didn't answer the box, but if Skip or Derek, I hope they can answer a couple of the questions if I get to disappear because of the power
I'm
situation.
here, Alfonso.
Nice. So I get Margie can cover me. Anyway, so this project is called Measure the Mug, and that's like the cute social name that we use to gather the social science, the citizen scientists, but in a more scientific formal way. What we're trying to do is study the water quality impacts from tidal flooding events, specifically in the lower Chesapeake Bay, and more specific using the Lafayette River. We started doing like a bigger region, but then we decided that it was better to focus in one region, as Derek mentioned before, like repeating spots help you to validate, and in terms of nutrients or water quality, having that validation is even more, I think, important, especially because we cannot get as many points as just dropping, with the phone like this. Water samples have a process, so that reduce a lot the amount of samples that you can get. So anyway, this is here is my name and my email address in case you have further questions after this. Before jumping, I wanted to thank before the volunteers give the credit to the people who is involved in the research component of this project. The leader of the lab, Margie Mulholland, who is also here, going to cover me if I disappear, right here explaining to the volunteers in 2017 how to do the sampling and the mapping. Here is Pete Bernhardt explaining also part of the doing part of the training, who is our lab manager and doing sample processing and analysis and all those sort of things. I just graduated Dr. Selden now, who has been a crucial part for the collection of samples, analysis, and data analysis. And of course, Derek, who has been like a critical part of the models and flux calculations that we're trying to do with this nutrient data that we're collecting. The next step that we're doing with it is trying to estimate amount of nutrients getting into the system. So anyway, so the idea behind this is going around flooding in the area. You see, I bet you all have done. You all have seen this type of images. Like you have trash cans in the flood water. You have water pushing back to the drain, and then in the right you have this picture of poop that we hope is from a dog or an animal like that, and not anything else. But you see a lot of images. These are just three. We have a lot of images that our volunteers and ourselves have collected during sampling. So the part of the question was like, okay, what is happening in terms of not just the physical component, like the water coming into the city and that, but in terms of like water quality, nutrients. So what is it? What is this Measure the Mug project? We invite people, citizen scientists, interested in collecting water quality samples from flood water. The volunteers range or have ranged from 2017 to 2020, from high school or even younger volunteers to their parents and their teachers, as well as professors and graduate students from ODU. And this part of the thank yous, like for us, this means a collection of data that we wouldn't be able to do without this army. Like as I bet it's true for the Catch the King project. Like, yeah, I can go myself. I actually go myself through the year at different flooding events to collect samples and compare in different weather conditions. Has been raining, not raining, etc. So because it's only myself and sometimes Margie and sometimes a couple of the grad students that come and help me, we collect 20 to 40 samples, let's say. So compare that with like the 200 samples that we can collect and swipe the entire Lafayette perimeter. This is just a amazing opportunity that it gives us. That's for us. And for the volunteers, we try to give back some of this. So we give them the chance of being part of this collection of data that hasn't been done before. So we're creating numbers to then have a solution for a problem. Hands-on sample collection and processing. If they volunteer extra, they can not just collect the samples, but stay on the lab, and as you can see on the picture on the right, and help us processing the samples. And then also when we get them for training to how to use the phone app, the Sea Level Rise app, and how to do the water collection the day of the event, we try to walk them around, especially like the younger, not just the younger volunteers, but especially them. We try to walk them around the labs, tell them the instruments that we use, how we use them, the relevance of them. I don't know. We're trying to give a little bit more of inspiration, feel that curiosity that they have. So that's before the event. They come to the lab, they get the phone app and how to use it and stuff like that. So the day of the event, they come to the place, collect a sampling kit, which is a cooler with ice, the bottles to collect the water, gloves to be protected, a board to write down extra information that we need, like backup information that it's already going to be in the app, but we want like a double check. We also give them a map of the showing the Lafayette River and the area that they have to go and collect samples for. Of course, at that point, at the point of the sampling, they already have the phone app and should know how to do the drop the pins and make a picture and things like that. And we do not provide rubber boots, but we encourage them. A couple of years, like a couple of the volunteers have been there without boots, so we encourage them a lot to wear the boots. This is just an example, kind of how it looks, the water quality samples versus the flooding pins versus the sea level rise pins. Let's say the red is a place where you're gonna collect, for example, you drop your pin, take your picture, and then keep going, dropping pins. Again, you can collect more pins because it's just the extent of your thumb, of your finger. But water samples, we need to space them a little bit more because of the time and money that the reagents cost and the filter that we use cost, like things like that, and also the time for processing all these samples. So we space them more. At the end, we end up with something like this, like all these many the limitations of the flooding and all these many flood water samples, water quality samples for a given region. And kind of like in a more realistic way, this is a picture of me. You will take one at the beginning, let's say, of the flooding mark, one more in the middle after 5-10 steps, another sample after another 5-10 steps, and you will put it back in the cooler that we give you. And you keep going until you finish your region or the bottles that your cooler contain. So this is a video. Don't panic. This is 2019. So this is a video kind of like how the lab looks after the sample collection. We have, again, some of these very young volunteers, some of the scouts from the Girl Scout group. We have grad students. We have a lot of people. Again, we need an army to not just collect all these samples, but also to process them. So previous years, we have had, okay.
It looks like we may have lost Alfonso, but he has sent me his slides, so I'm going to take the reins again and move forward.
Let me know if you need me to interject.
I was just going to suggest that. Yeah.
Yeah.
So I have a pickup where Alfonso left off. So he was talking about the sampling kit and moving forward. Can you see my screen okay, Margie?
Yeah.
Excellent. Do you want to speak to, I guess he pulled up a video in between, or it's this slide, I guess.
Yeah.
So the modifications due to COVID-19, what types of experiences do you have?
Right. Well, this year, in previous years, we've been able to have the high schoolers, Girl Scout troops, and a lot of different groups participate. But this year, because of COVID, we did a sort of truncated version where we really just used graduate students at ODU, mainly people who were living in the same houses. We were teaming up family units, and we had contact-free pickup and delivery of the coolers. We did it curbside, or some of us took them home the night before, so we didn't all have to meet in the lab. doing that. So it was, yeah, I think that says everything on that slide.
Definitely.
And fortunately, we were still able to collect almost the same number of samples with our smaller group. I think it was, we missed having the kids involved because of the outreach and because of their excitement and interest, but we just couldn't do it this year because the schools aren't in session. We had a lot of kids from Maury and Granby High School, and we just couldn't do that. But we were still thrilled because we were able to get a huge number of samples, about 150 this year from the Lafayette River watershed. Okay,
Wow.
the next slide.
It's incredible.
Yeah, we were really happy about it. The focus of Alfonso's research has been to quantify the nutrients going into this particular tributary. To do it well, we need a huge amount of data that's synoptic from a small place. And so we decided to focus on the Lafayette River because we actually have a time series site at the Norfolk Yacht and Country Club where we have instruments moored there. We have 2 instruments moored at the yacht club and then one other moored near the headwaters. But this figure shows the ammonium concentrations. That's one of the forms of inorganic nitrogen that occurs in natural systems. And nitrogen is the key element that is thought to contribute to the nutrient over-enrichment of the bay and so the water quality problems. And one of our motivations for even doing this is because we know that this loading that happens during coastal flooding events is not included in any of the loading models that the Chesapeake Bay program has. And they're very anxious to know how much is coming in during these flooding events, because we know it's probably quite extensive because we can see the chunks going in. And so we've been very concerned because how can you hope to restore the bay if you're not even counting a large portion of the nutrients going in? It's sort of like cheating on your diet and, not counting anything you eat when you're standing up or something like that. So, so we really want to get a handle on how much nitrogen in particular is going in during these flooding events so they can start including it in the next generation water quality models. But this is a figure just using a bubble plot showing the relative magnitudes of ammonium concentrations. Normally, you may or may not understand the units, but normally it is very difficult to detect ammonium even in some of these systems. But here you can see that there was quite a lot. This is in units of micromolar, so there's quite a lot. It's less than 3 is sort of a normal range, and that's sort of around what we saw in the bulk of the river beforehand. But you can see in these floodwaters, the ammonium is highly enriched. And so what we're doing is we're trying to collect enough data and then interpolate that between points to calculate an average load of the nitrogen. So I think next slide we can go.
And these are in units of micromole per unit volume, like per liter?
Correct, they're micromolar.
Per foot
So
square?
micromoles per unit
Okay.
per liter is
Okay.
what the unit is. And so if we
Wow.
know the floodwater volume and the concentration, it's sort of like calculating a flow rate through a river. If we know the volume and the concentration, we can calculate the amount by simple division. Right? Well, it's multiplication really.
Yeah.
So, but another thing that we have been able to do with contributions from the Hampton Roads Sanitation District, who actually supports this entire effort, and the Virginia Department of Health, is in a subset of samples, we also collect water to measure Enterococcus, which is a fecal indicator in the bacteria. And this is just a figure showing the amounts in each of the 4 years. People are always appalled by this because the swimmable, fishable standard is this green. I think it's 104, and the units are MPN, which is a most probable number, which frankly it's a weird unit, but this is what the regulators, this is the unit they use for establishing fishable and swimmable waters. And so 104 is the actual number. And so you can see in all of these samples collected, we rarely achieve that. And this has sort of appalled me because I know during flood days now, they get off school and the kids just treat it like a snow day and they go out and play in it. And you'll see kids splashing around, getting out their little boogie boards and playing in it, and pets wandering around drinking it. And so it's really a cause for concern.
Wow.
Yeah. Next slide.
That's intense. Yeah.
Yeah.
It's maybe a kayak
really
is the safest. Swimming. Yeah, I think that was the last slide. It just goes
was it?
whole slide after that.
Yeah, I actually wanted to say though, in our 2017 calculation where Derek from his model and all the data that you all collected, he was able to calculate rather a volume of floodwater. And I just want to say that the nitrogen load delivered during that single flooding event in 2017 was the entire annual allocation for nitrogen allotted in the total maximum daily load, the TMDL, for overland runoff. So we believe that the number is really big, and so this is going to be a very important contribution to the Chesapeake Bay program modeling and restoration efforts. So.
Wow.
Yeah, and we are doing other efforts now because we know all the flooding events are not equal. Okay, we know that there's variability because sometimes the landscape was dry and there's a lot of stuff that's accumulated on it. Sometimes there's been a big rain event like out my window today and the landscape's been washed a couple times. So we've picked about 8 sentinel sites, we call them, that we try to go out and sample almost every time it floods. And by we, I mean Alfonso. Every now and then I'll go out and help and maybe go out with one of my kids or Skip. So, yeah. But we're happy to take any questions.
Absolutely. Does anyone have any questions for Alfonso or Marchie?
Hi, this is Dawn. So you're doing these samples down in that area that you're talking about, but are you trying to get those water samples up on the northern neck or?
We would love to do that. We would love to expand our ranges for each region to get, what happened the first year is we actually did try to go to multiple places around that flooded, but we found we didn't have enough data to make a good assessment for any place then. So we wanted to do one place really well. And it's actually a really complicated thing because you have all these people, you have hundreds of samples coming in, and we just couldn't really handle anymore with the personnel we had and the lab size. What we're hoping is to get additional funding from NOAA or some other federal source that we can expand into other branches. And then the idea is to, if we can, well, first let me back up a little bit. The Sentinel sites were selected sort of because they flood, but they represent different land uses as well. And so the idea is to expand the program, establish more Sentinel sites that encompass the whole variety of land uses that you might have in the region. And then we could use GIS and other mapping tools to try to extrapolate what the loads might be like in other areas. But it would be great if we could have focused efforts in a number of regions that represent a number of disparate land uses.
Right, because you have residential, you have commercial, you have industrial. So there are all types of water infiltrations going on.
Right, and in the Lafayette River, it's primarily residential. Mm-hmm. And the other thing we're trying to expand, and Mike Unger actually analyzed polycyclic aromatic hydrocarbons in the floodwater this year as well. So we would love to analyze other possible contaminants that are entering our waterways as a result of the flooding.
Right. Okay, well, then I'll definitely be on the lookout.
Yeah,
I'm sure you guys will be notifying.
Yeah, we've been trying to engage schools we need to right now just manage our size. Right. And so we've been actually reaching out to the AP Environmental Science classes. And so they come and bring their teachers, and we give them lab tours, and and then go give a presentation usually at the end of the year. This last year we weren't able to because of COVID.
Right, right.
But once they've done the AP exams, they're sort of in freestyle mode.
Mhm. Right. Well, thank you.
Hey everyone, this is Jim. A quick question with regards to the water contamination link that you shared. Whenever we do have flooding events, I too try to encourage folks not to play in that water. Are you able to share with me the link where I could provide some of those graphics to folks to show them in a tactical way? Obviously, I'm sure I don't want to, from the city, say our water is dirty.
Right.
But I also want to make a point that, you know, there are contaminants in the water and that you should not play or drive in that water.
Right. Yeah. We'd be happy to share anything with you because we actually reached out to the city to support some of the proposals that we've tried to put in to get more funding, but we haven't had any luck getting that funding yet. But we'd be happy to because it just makes me sick. And we did know a child that was hospitalized because they had an open cut on their leg and it got infected playing in the floodwater. So.
Gotcha. Well, let me be your point of contact for the city. We're trying to do some things to consolidate our mitigation planning efforts. I'll send you my email in the chat, and we can talk offline.
Perfect. Thanks, Jim.
Awesome. Thank you.
Any last questions for Margie?
And I apologize about Alfonso's computer and the power out. He's had a bad day.
Excellent. Well, next up to briefly speak is Skip Stiles.
He's downstairs.
Yeah.
Filling out the basement.
Yeah, he gets the downstairs. I get the upstairs.
Margie took over the whole office, so I get the downstairs. We're part of a team here. I really do want to thank all of you for what you've done. We developed this app way back in ancient times for apps back in 2014. And the goal was to begin to crowdsource the information that from people who were experiencing flooding in their neighborhoods and begin to give it to modelers like Derek, emergency managers like Jim Reddick, who was just asking questions of Margie, and basically jumpstart the solutions to our flooding problems by harnessing the energy of all of you folks out there. And it's just, it's been amazing to watch this thing expand around the hub of the King Tide. You know, we've got some additional work, Margie's work, Dr. Mulholland's work, Measure the Muck. You know, you've got a bunch of people out there. Let's have them do some additional stuff. What we'd hoped was that this app would become a platform for other work. We've also begun to sort of expand a bit of it. I will real quickly show you. We had some people this year running drones. This was not King Tide. This was that flood we had the day before. But we've had people out running drones on some of these flood events. So now we're beginning to expand beyond just collecting the data and actually getting some visuals of it. Going forward, you know, for us, Wetlands Watch, the data was important, but as important, more important actually, was the development of a network of people connected throughout Tidewater, from the northern neck down to Pungo, around this solution of this common problem. And what we want to do, and what I think we're moving towards, especially with the expansion that we've had in the Middle Peninsula and the northern neck, is that network of people. And so going forward, what we're hoping to do is to expand this network. We're looking now for funding to update the app. We're going to come back to all of you, the constant mappers, the experts in this, to do what they call a use case study to find out what we need to have in the next version of this app. We want to hire a full-time organizer. Karen has slipped away from us with a full-time job, so we're probably going to look to try to raise money for a full-time organizer, because what we really want as well is for people to begin organizing themselves into pyramids. The original idea for this was that like you all on this call would become the top of a pyramid of people who would be mapping and could establish your own events and go out when there were flood events in your neighborhood. So for example, instead of just doing the king tide, a flood event like today hits in Norfolk, a team in Norfolk hits the streets, you collect that data. The rainfall data is really, really important because it's completely unpredictable and it's increasing in intensity, and it's the kind of thing that cities and counties are going to need to start dealing with going into the future. So I guess what we want going forward is we want to run this thing year round. We want to expand it throughout Tidewater. We want organizational nodes in every area, either new people doing the work or using organizations like the Master Gardeners, Master Naturalists, Girl Scouts, Boy Scouts, whatever, to begin to develop mapping nodes in every part of the state that become sort of independent operating units, so that when an event comes up, the head of that node would alert the mappers, hey, we need to get out today because there's, we got 6 inches of rain here in Norfolk and it's flooding on Princess Anne. So that's where we'd like to take this thing, and we're going to stay in touch with you over the coming year to begin to expand that. And so I just really want to thank you all. I'm really excited about this partnership with the Colonial Coast Girl Scouts. That I think is going to be a real expansion. We'd like to go back and renew the work that we had done. WHRO here in Norfolk developed SOL compliant curriculum for high schools. We want to go back and renew that. So it's real exciting. I'm hoping once this COVID thing gets fixed that we can take a real leap forward in energy, and we'll be coming back to you because you all are the backbone of this organization. So I want to thank you, and we'll be coming back to you in the coming year.
Absolutely. Thanks, Skip. I appreciate it. I think at this time we are going to be moving forward to our kind of structured Q&A session at this point. So we just kind of want to open the floor for questions from our volunteers.
Questions and comments. If there's anything the volunteers would like to share with us about your experiences during the mapping, or challenges that you had, or any suggestions that you have for us to improve what we're doing, we'd be happy to hear all of that as well. So this is just sort of an optional time for us to give you an opportunity to let us know what you think, and if you would like to stay engaged, how you would like to do that. So is there anybody who would like to speak or ask a question? You can turn your video on and unmute yourself.
And as you're kind of doing that, just wanted to add a note to thank you all for those of you that have joined us. This kind of ends our formal program. This is more of our informal Q&A to all of our volunteers. There are no more presentations beyond this point, but we would love to hear from all of you. So please.
There is a question in the chat box, Derek, that said, was there an event created for today to map the flooding that happened today?
There was not.
So there are currently no plans to create events into the near future. Is that correct? Mapping events in the app.
Right. We've mostly focused on storm tide and king tide flooding events. We're certainly interested in data from rainfall events. However, that kind of requires that we know that it's going to be really bad before it actually ends up happening. It was forecasted to rain today for sure. We weren't expecting how much rain it was going to be until probably the several hours right before the event took place. So the other challenge with rainfall events is, of course, we're using phones to map the events, and a lot of people are averse about taking out their phone in a massive rainstorm. But that doesn't prevent you from going out afterwards and collecting data. It's just one of those things that's kind of been amusing, that we tend to find that most of our successful mapping events take place during daylight hours. And most of the time that it has now stopped raining, it's after dark for an event like today. But it will, of course, continue to rain. So
Karen,
not an event today.
Karen, people are free to set up events on their own. And one of the cheapest and best fixes I've seen to the rainfall is just put your phone inside of a Ziploc bag. That's one of the cheapest workarounds I've seen for for dealing with a phone that's wet. In fact, I always map with my phone inside a Ziploc bag, having dropped one already.
And you're correct. I mean, anybody can use the Sea Level Rise app and create your own mapping event. And Joe just put into the chat box that Virginia Beach has a mapping event for the November spring tide on the 15th of November. Joe, would you like to tell us about how you set up that event and how that's working for Virginia Beach?
Hi, I'm not going to turn on my camera because I'm eating dinner and I don't want to gross anyone out. I have a tide mapping team in Virginia Beach that maps the monthly highest tides, the spring tides, every month. What I do is, starting with the NOAA tide predictions, I extrapolate my own predictions for about 36 different sites around the city and send that to my tide mapping team about 4 or 5 days before each month's spring tide. And then when after the mapping, I download the data and send it to Derek. So we have several locations that have been mapped every month for a year now, in addition to the king tides.
So the steps involved are sort of setting up your own mapping event inside the app, and then that gives you control over downloading the data, and then you have a communication link with Derek to send him that data so that he has access to it. So
that's how it works.
And you have your own sort of team organized. So this is anything that any of the other groups or teams could do, such as on the Northern Neck or the Middle Peninsula or any neighborhood group or even the Girl Scouts or even, smaller groups, even if it's just, a handful of people. So that there are steps for that. And we can try to document that, or we can answer any questions if anybody's interested in doing that on their own.
I sent you and Derek samples of my map of mapping locations in Virginia Beach and my predicted times of high tide at various locations, which I go back and validate my estimates twice a year. So they're pretty accurate. And feel free to share that with anyone that may want to try and do the same thing.
Great, that's excellent. For the Middle Peninsula and the Northern Neck, we use the Coastal GEMS map to find mapping sites, and then I use the NOAA tide prediction sites to try to estimate the times of high tide. So it'll be interesting to compare our methods. Belinda, you had your hand up?
Yes, hi, I'm Belinda Willis, and I'm a mapper in Yorktown on Yorktown Beach. And I always encounter people while I'm walking the surf with my phone. Nobody is ever bold enough to ask me what the heck I'm doing, but I get lots of curious glances. And it occurred to me that that is a real good teachable moment for people, especially kids that I encounter that are looking at me and thinking, what are we doing? But I'm wondering, what kind of publicity do we have that goes out before a Catch the King to say, look out for the mappers, or who are those people on the beach type of thing?
That's a great question. Skip, do you want to take that one as far as sort of, can we develop some sort of promotional materials or a postcard or something that could be handed out?
In the past, we've had, back when we had newspapers, we had the full cooperation of both the Daily Press and the Pilot, and a lot of that news got out through them. We had some TV coverage. It's been a challenge this year because of the COVID and because our newspapers are disappearing. And we should think about ways to get that information out there. We do, of course, do a lot of work on Facebook, but you have to have already been hooked in. So that's an interesting idea, figuring out how we could get more of that word out. Again, we've depended on what they call free media through our media partners in the past, but we should be thinking about different ways of doing that. That's a good point.
We have a very active tourism department in Yorktown, and they've revitalized the Riverwalk area. If you've been down here, we have weekly farmers markets. So it's possible one could set up a table. I'd be willing to do that just to educate people, or even we could get some publicity through York County Tourism about what the people are doing on the beach walking through the surf. So I'm happy to help with that if anybody has any ideas or needs connections.
Those are excellent suggestions, Belinda, for public outreach simultaneous with the data collection efforts. And it could be that for each team, there's a dedicated volunteers who are providing public outreach support while other volunteers are concentrating on collecting the data. I think those are excellent suggestions that we can think about and work on. There was another question about how do you create a mapping event in the app? And Derek just answered some of those questions, provided some information in the chat box about how you can set up your own mapping event within a private region, as well as Karen gave a suggestion for within the Catch the King region. So read that information, Bo. Hopefully that will help answer your question.
Admittedly, we haven't taught a lot of people how to do this because I think our inaugural year, everyone was setting up their own regions and then their own maps, and then it was very hard to find the king tide mapping regions that we had set up. I think at one point we finally had to download and archive all the data in 2017, but when we had hundreds of volunteers creating their own regions in Norfolk and Virginia Beach. It was really hard to find in very dense urban environments which one was the right one to map in. But basically the way it works is you have to manage your own region, so you can create a neighborhood or community within the Sea Level Rise app and then generate events within that. And I have several volunteers that send me data individually. The main challenge is mostly that you do have to directly send me the data. I don't get the data from the sensor or from the individual regions that you map. So you still have a data delivery requirement since we cannot see the data that are in private events, only those that are public ones that we manage. And Cindy's got a good example there as well. Hats and t-shirts and merch, huh? We do have a King Tide shirt that I wore for one of the interviews when I was on the Weather Channel, but there are very few of them around. They're a limited edition from when they were printed a couple years ago. But I think I saw in Alfonso's presentation that some people were wearing Catch the King shirts from 2017 as well. So,
but I think there's also a lot of effort, Skip, if I'm correct, at the state level to sort of help every citizen understand their flood risk and understand evacuation zones and where they are and where they live in the flood zone. So these are all, there's a lot of tools I think that we could utilize for outreach events and helping people also set up their own mapping and collecting data in different ways.
Yeah, and there also are a lot of partners. I mean, the voice on the phone earlier was Jim Reddick, who's the emergency manager for the city of Norfolk, and he has been a good partner of ours in a lot of work and would be a natural match for this as well, because his thing as the emergency manager for Norfolk is making people more aware of the flood risk. So this is the kind of thing, if we had a full-time year-round organizer establishing these kinds of relationships with the emergency management folks up and down throughout Tidewater, we could begin to develop this outreach, get more people, get denser data sets. The whole thing begins to grow. But this Catch the King event is great because it's the backbone. You the volunteers are the backbone. And if we can get a little bit of organizational partnerships going, I think we can expand this thing quite a bit.
Definitely. I know I saw a message from him in the chat on Facebook earlier mentioning on the live stream there about CERT volunteers and integration potentially within the city there. And I can acknowledge that I know in 2017 and 2018, we did do this with Newport News' CERT volunteers, where I ran 2 different training events for those individuals there. So there's definitely an opportunity to integrate with CERT volunteers from an emergency management standpoint. I think
Eric, can you tell us what CERT stands for?
Why am I blanking on the fly?
Sure.
Yeah, I can.
Go ahead, ma'am.
CERT stands for Community Emergency Response Team, and every county and city has volunteers who support the emergency responders in their community. And I'm a CERT volunteer in Gloucester County. And I think it's an excellent suggestion to crosswalk flood mapping citizen scientists with the CERT volunteers to help each other understand what they do.
And I seem to recall that the city of Chesapeake's counterpart to Jim has expressed some interest in the past also in energizing his CERT volunteers to
definitely Rob
participate in the project.
Yeah, Braidwood's quite he's a class act, and they've got a very active crew down there. That would be a good one. And I mean, the Colonial Coast Girl Scouts, there are 10,000 girls in the Colonial Coast Girl Scouts chapter. So, there's another partnership that yields amazing reach.
I have a question for anybody in this, since we're all learning things like this forum, Zoom, is there anything that we can take out of sort of our new way of doing life right now that, that's hopefully temporary, but, that will have some permanent, I think, effects that we can use to improve our project? If, for instance, is Zoom a tool that we can use for training, or is there some other way that we can reach more people?
I think Zoom has a lot of potential. I think it can overcome a lot of the geographic barriers. I think, though, that what we found both with the app and with Zoom, once you get into rural areas and there's no broadband, it rapidly falls apart. There are places on the Eastern Shore where we can't run any mappings because there's no signal, and there's places on the Eastern Shore where you couldn't run a Zoom call because there's not enough broadband. But I think we can certainly use it to expand our reach into a lot of areas where it does work. It allows you to reach a lot more people a lot more quickly.
Pardon me.
And we actually thought that was going to be a challenge on the Northern Neck. And if there's, I see there's still a couple people from the Northern Neck here. Did that really turn out to be a challenge for you, either for Zoom training or collecting the data using cell phones? Did you have enough cell phone coverage?
Hi, I'm on the Northern Neck, and I mapped the Cabin Point beach, and the signal was very strong, and it went smoothly.
And hopefully our broadband limitations are going to be closed, so all the gaps are going to be filled in soon. I know there's a lot of interest and effort to try to do that.
Right. Well, I don't recall how I found out about this Catch the King, but it's something that I jumped on immediately, and then of course became a member of your Facebook page, but it's by invite only. So then beyond, we have, the Facebook medium to reach out to people, and then plus, I have just been spreading the word all around both Glebe Harbor and Cabin Point, to all the people who live here, and to get involved, for future mappings. So hopefully that'll work.
Yeah,
Thank you.
I think everybody's thinking about how to use social media more effectively now that we have to rely on it more than ever before, and to use it in an effective way.
Mm-hmm.
If you don't mind, Derek, I would like to back up to a question that came in earlier, because this is something that a question I get often is about some of the data points kind of going, what we call going rogue. I don't know if you saw this, that up in Colonial Beach, and this happened to me at VIMS, if you remember, I asked you about it, where some of the points that are collected end up far away from where the person's actually standing. And here he says that we had a lot of rogue data points showing up in the town instead of on the shore. Is this an app issue or perhaps being too close to some interference, like for them, it's Dahlgren, a military installation. Do you have any comments about that? We can't hear you, Derek. And it doesn't look like you're muted.
Sorry. Yeah, I wasn't muted, but yeah, sorry about that. Basically, there are some challenges related to how enhanced GPS on mobile devices functions just within any app, not necessarily the Sea Level Rise app. So naturally, of course, there's GPS from the surrounding satellites, but then it is tethered to nearby cell towers, which can pull your points towards wherever that tower is, especially if you only have one tower near you. I've seen this happen in Gloucester Point occasionally with some of my earlier cell phone models that I was using back in 2017 when we first started this event. Now most of our modern cell phones have multiple antennae in the tops and bottoms of your phone, and so more of those combined with the enhanced GPS signal of multiple overlapping towers. If you're within the radius of multiple towers, that tends to help a little bit. But you'll still wind up with some random points in the water occasionally. We're not exactly sure why that will happen sometimes. Like some will be way out in the water. And I don't fully have an explanation as to why that happens. There are other random spots in Norfolk and other places that are known to us as well where there's lots of overlapping cell towers. But it's possible there's some form of interference that's moving those points away from where they're being collected. And that may be local interference and just a location. So it could be that, the facility there at Dahlgren is messing with the measurements that are being collected at Colonial Beach. I'm not sure. Since this is our first year, we've had people map out there. So I'm interested to take a look into that, since I know NOAA has a gauge there and there are federal facilities there that could possibly have some form of signal jammer that's affecting that, but I'm not sure exactly what it would be at the moment. Most of my experience is due to points that are being migrated towards the nearest cell tower on peninsulas that only have one tower that you're in range of. And you're usually on the edge of the radial range of whatever the throw distance is of whatever cell carrier you may happen to have that has least space on that tower. There's a lot of variables that are involved, but in my experience, I've tried to explore what was going on with data from 2018 with Catch the King, where we had lots of people on the eastern shore that seemed like none of their points were lining up with where they were supposed to be. And a lot of it's attributed to only being in range of one cell tower. And even then, they don't have broadband carrier signal from there. It's just, it's not LTE or even 3G. It's just whatever you get. It's usually 1X signal.
When Jeff and I talked about this after the event, I suggested that he sort of get different devices to map the same areas together at the same time and see if it is an older device issue or are they all doing the same thing, which would sort of point to the interference issue. Was that good advice to provide him?
I would say so.
Okay, good.
I mean, we don't want to advise that you need to go buy a new phone or something.
Oh, no, exactly.
You have multiple devices to test this with. If that's an available resource to you, you might want to try that. I know I've found different results between two different phone models I'd used, and I seem to go back to the hardware differences between an older iPhone versus a newer one, having two antennae, one at the top and bottom, versus the newer models that now have four, one in each corner. So hardware differences among phones, individual cell carrier plans, where those individual towers are located. And frustratingly, right now with COVID-19, a lot of these companies are actually turning off some of their contracts with cell towers right now just to maintain their bottom line. I've found this in different places where I don't normally lose signal, especially in Shenandoah Valley, that I am now, and in some areas on the eastern seaboard when I was driving to the Outer Banks and further up on the eastern shore of Virginia, where I don't normally lose cell signal with my normal carrier, but I did recently. So what I've traced it back to is apparently lapses in contracts with cell towers. So some cell carriers are cutting their contracts with different towers where you previously had service, but now you don't have as much service or it's not as good.
Well, that's out of our control, isn't it?
Exactly. But at the same time, I do have an explanation for it. So there is that. It just doesn't fix the problem.
Right. And Lynn just asked another frequently asked question that I get often in the chat box. She's on the Indian River off the eastern branch of the Elizabeth River, and most of her side is bulkheaded. And the water's a few feet below the bulkhead. So I'm assuming that the tide line is sort of on the face of the bulkhead. And she wants to know if her mapping points are useful. And I have told my volunteers it's very difficult to map along bulkheads and revetments or riprap. Riprap is very dangerous to be walking along anyway. But are those points useful to try to map the tide line that are sort of on those defense structures along the shoreline? Or should they just really be focusing on if the water comes over the top of the bulkhead, where is that water line, and map there?
So that's a great question. We get this one occasionally because there are large portions of Portsmouth and Norfolk that are bulkheaded as well. And the unfortunately odd answer to that question is that, interestingly enough, no, the data points are not actually that useful if you're just mapping the edge of a bulkhead. It's really only useful if the water is exceeding that bulkhead and flowing into your yard or whatever space is on the other side of it. I personally, as a modeler, love those points because our model is going to be right whether the water level is plus or minus 3 or 4 feet in some cases on the vertical scale. The spatial extent of those points is still going to be the edge of that wall that you're walking on. So it makes our model look really good because all of it lines up perfectly, plus or minus whatever vertical difference there would be there. But the short answer to that question is that it is not particularly that useful unless the floodwaters exceed that wall. At that point, now the points are particularly interesting and useful for our model to know that, okay, the flood wall is exceeded. However, it is nice for our model to know if we're close to, but don't exceed the elevation of that wall. It does help us to know, whether or not the points are along that wall, but it doesn't help us to map it when the water level is 3 feet below the edge of that the bulkhead. But it would be useful for us to know if those points still align along the bulkhead and the water levels within 6 inches from the top of that wall, or waves might be lapping over it. That's something useful for us to know. So it's an odd answer to say yes and no, but in this case, yes, if water is overtopping the wall, no, if it is not.
I hope that answered your question, Lynn.
Apologies for the complex answer.
She says absolutely. Great. Is there, it's a little past 7:30. So is there anybody else who has any other comments or going to want to cut off this great conversation? Any other questions or comments?
Of course, if you're watching this on Facebook, your questions will persist after the event is over with, so we can respond to them there. But also, of course, we're available by email. If you have questions that you don't think about in the moment but want to ask later.
Well, I would certainly like to thank you, Derek, Dr. Loftus, and Skip Stiles, and Dave Mayfield, and Karen Jacklich had to leave, our volunteer coordinator. A lot of their time is volunteer as well, and we really appreciate all the efforts of the coordinating team and our sponsors for giving us citizen scientists an opportunity to participate and to collect this data and help.
Absolutely. Thank you all very much. We really appreciate your time and efforts. And thank you, Karen, for helping coordinate and MC this event. And to Karen Jacklich, who has been instrumental in our successes with this project and program over the last several years. Apologies, as I'm not particularly adept at answering every volunteer emails they come through. At a certain point, I have to pretend to do research, or I don't get to stay employed at the Virginia Institute of Marine Science. But without Karen's efforts at tirelessly responding to a lot of your questions and comments and kind of passing along questions to the appropriate folks that help run Catch the King, we really wouldn't be able to be where we are today. So we greatly appreciate her tireless efforts in coordinating our volunteer base. And thank you to all of you, our volunteers, for making it happen.
And let's stay in touch and stay engaged as much as we can.
Absolutely.
Thank you.
Well, good night, everyone.
Good evening, everyone.
Good night.